Hello there, welcome back to my channel. A river is flowing due east at a speed of 3 meters per second. A boy is rowing a boat at 5 meters per second in still water from the point O, here shown on the diagram, on the south bank and steers the boat at right angles to the bank. The boat is also being blown by the wind at 4 meters per second, southwest. Taking axes OX and OY in the directions east and north respectively, find the velocity of the boat in the form Pi add Qj, and hence find its resultant speed. So as you can see, the most important thing here after reading the problem is for you to produce this diagram here. We have our directions here, our compass, and then we have a sketch of the boat and the data supplied in the problem. So one of the first things we can do is to determine the velocity of the river. And we're told that it's flowing east at a speed of 3 meters per second. So it's going in this direction, 3 meters per second, which corresponds to the unit vector I. So the velocity of the river, we can write that as 3I. Next, we have the velocity due to rowing, and we're given that as 5 meters per second in still water from point O on the south bank, and it's steered at right angles to the bank. So that's going north, and we can write that due to rowing is 5J. So these are the two things we've determined so far. The velocity of the river at 3I, that's in the positive unit vector I direction, or going east. And the velocity due to rowing the boat is going north, 5J. Now we have the velocity of the wind. We're told that it's 4 meters per second southwest, and that's indicated by this arrow. But in order to find the components, we need to resolve 4 meters per second. Now, if it's southwest, then it's at 45 degrees to the south. So it's, we were to just show you a dotted line, it's southwest. So this angle is 45 and this angle is 45. So we'll resolve it in both directions to determine the components. So we'll have minus 4 cosine 45 degrees I. Because we're resolving this in this direction, so it'd be pointing in the negative I direction, and minus 4 cosine 45 degrees J. And we resolve it in this direction, it's in the negative J direction, so it's minus for cosine 45j. So the resultant, or if we were to just put this into the calculator, so it's minus for cosine 45 degrees. We know cosine 45 degrees is root 2, so multiply by minus 4. And likewise for cosine 45 here. So what we have is this being equivalent to minus 2 root 2i minus 2 root 2j. So our resultant velocity v is given by v equal to, we're going to add 3i, 5j to the corresponding components here. So 3i will be added to the I component and 5j to the j component. And so we have 3i add 5j added to minus 2 root 2i minus 2 root 2j. And this gives us 3 minus 2 root 2i added to 5 minus 2 root 2j. Note the use of brackets for clarity. So now the resultant speed now, and always is, a quantity, a scalar quantity, which is the magnitude of the velocity. So it is the magnitude of the velocity of the resultant velocity, sorry, because we have found the resultant velocity in order to find the resultant speed. And that's denoted as this. That's how we denote the magnitude of the velocity, and that's where the root 3 minus 2 root 2 squared added to 5 minus 2 root 2 all squared. And this follows right through. And our final result is root 50 minus 32 root 2. So let me just tidy up this. It looks a bit wobbly. And that's our final answer. We've found first the resultant velocity, and finally we found the magnitude of that resultant velocity, which is the speed, the resultant speed, which is root 50 minus 32 root 2. I've left it in this form because this is the most accurate form. If you wanted to do further calculations from here onwards, let's say the problem was extended, this is what you should actually use. If this is your final answer, you could approximate this or just leave it in this form. Thanks for watching. I'm Alistair. Please remember to subscribe, share, and like this video if you enjoyed it. Bye for now.